In this lecture, we're going to take a look at the Enhanced Interior Gateway Routing Protocol, or EIGRP. So what is EIGRP? It's an interior gateway protocol, and much like RIP and RIP version 2, is a distance vector protocol. It has many differences, though, from the open standard RIPs. Namely, it's Cisco proprietary, which means it can only run on Cisco equipment. It actually stems from an earlier protocol called EIGRP, or Interior Gateway Routing Protocol. EIGRP was introduced back in the 80s to overcome some of RIP's inherent limitations, namely its 15 hop count limit. It also included the ability for better scalability, for able to determine metrics based on bandwidth, and just basically more reliable. Its main downside, though, was the fact that it only runs on Cisco equipment. Well, by the early 1990s, our networks no longer classful, they were classless, and RIP was updated to RIP version 2 to add this flat classless functionality. Likewise, Cisco updated EIGRP to EIGRP to add this classless functionality. How does EIGRP work? Well, it forms what's called adjacencies with its neighboring routers. So once the router is turned on, or once the routing protocol is turned on, it'll try to introduce itself to its neighbors. And it does this with an EIGRP hello packet. Once they exchange hello packets, the routers have what's called an adjacency. And it forms the relationships by which they will exchange routing information with each other. The algorithm for EIGRP is a Cisco proprietary algorithm called dual, or diffusing update algorithm. And by definition, this makes it a distance vector protocol. The idea behind it is that it's going to be loop-free, which means we won't have routing loops, and can form much faster convergence than RIP can. It does this by sending update packets after the adjacencies have been formed. And actually, much like TCP, a router will send an update to its neighbors, to its adjacencies, and then those neighbors will send back an acknowledgement. So the sending router knows that the update was sent. EIGRP also uses something called bounded updates, which means after the initial propagation of routing information, it only sends an update when there's a change. So if a line goes down, or if another piece of the network becomes available, and it only sends it to those routers that care about it. Compare this to RIP, which every 15 seconds broadcasts its entire routing table to anyone who's going to listen. EIGRP significantly saves on bandwidth by only talking to its direct neighbors, only sending updates when there's a change, and then only sending it to those neighbors who actually care about the change. EIGRP also introduces security. So if desired, the routers can authenticate with each other. In addition to authentication, they can also encrypt their routing messages. Now, like RIP, EIGRP will automatically summarize routes. So you can guess what's going to happen here. As we're configuring this, we're going to have to shut off auto-summarization unless we're using classful boundaries. EIGRP has an administrative distance for our purposes of 90. Compare this to our other ADs we've looked at already. Directly connected routes, an AD of 0, lower being a more trusted value. Static has an AD of 1. RIP had an AD of 120. And EIGRP has an AD of 90. So what this means is if a router has to pick between a route learned from RIP or a route learned from EIGRP, it'll pick the route from EIGRP because of this lower AD. Now, EIGRP routers are configured in something called an autonomous system. And we can think of this as kind of like a domain, almost like a Microsoft Windows domain, which allows the routers to talk to each other. And this is what lends to some of its scalability. We can define multiple autonomous systems in really large networks and control, as you can see by the diagram here, control how they're going to talk to each other. How do we set up EIGRP? Well, it's meant to be very easy to set up. And honestly, it's not that much different from setting up RIP, but it does have a few twists to it. The command to set it up from enable mode, we have to go into global configuration mode, so it's config T, right? Because routing protocols impact the entire router. Router, EIGRP is the command to turn it on. But then we have to pick an autonomous system number, or an AS number. Now this is a 16-bit value, so it can range anywhere from 1 to 65,535. It doesn't really matter what number you pick in that range. The key is, though, that all the routers in the same AS must share the same autonomous system number. Recommendation, pick a low number. 1, 10, whatever. What's important is that you be consistent. As we can see here, if I'm setting it up on 3 different routers, router EIGRP1, router EIGRP1, router EIGRP1. Don't forget, they must all share the same autonomous system number. Now, like in RIP, once the protocol is turned on, we need to broadcast what networks we're going to advertise, or select what networks we're going to advertise. And as a general rule, you pick every network that router is directly connected to. So if this R3 router right here is connected to the 192.168.10.4, the 10.8, and the 1.0, these are the 3 networks it would have to advertise. Now, because EIGRP is classless, this means that we need to also advertise subnet mask information. However, EIGRP does it in a slightly different way. It uses something called a wildcard mask. Now, we need to get used to this concept because lots of functionality in Cisco systems use wildcard mask. OSPF uses wildcard mask. ACLs use wildcard masks. This is a very common exercise we have to go through. And here's how it works. So let's pick just a regular Class C/24 net mask, 255.255.255.0. To get the wildcard mask, we subtract it from 255.255.255.255. It's just simple subtraction, right? So if I subtract this value from all 255s, well, 255 minus 255 is 0, 255 minus 255 is 0, 255 minus 255 is 0, 255 minus 0 is 255. So in this case, for a Class C network, our wildcard mask is 0.0.0.255. Easy. What about along non-classful boundaries? Well, let's take a look at 255.255.255.252, right? This is the standard net mask for a point-to-point /30. How do we get its wildcard mask? The same way. We subtract it from all 255s. Notice my last octet here. 255 minus 252 gives me 3. So my wildcard mask for a point-to-point network, a /30, is 0.0.0.3. And we just follow this no matter what the wildcard or the standard net mask is. If it was a Class A 255 0.0.0, what's our wildcard mask? 0.255.255.255. Easy. And here's the process by which we configure EIGRP, right? Now, if I'm not using classless networking, I don't have to give it the wildcard mask. For our purposes, we are using classless networking, so we need to give it the full net mask information. And you can see right here the example on R2, I've done just that. Right? 192.168.10.8 is clearly a /30 point-to-point network because of this wildcard mask. So the process by setting it up, router EIGRP and the AS number, pick a low number, pick something easy, just be consistent. And then from config router mode, you got to advertise every network that router can talk to or can see or is directly connected to. And you got to give the network identifier and its wildcard mask. As we said before, EIGRP does auto-summarize. So the last command we'll have to put in on each router, like we did under RIP, no auto-summary to shut down the automatic summarization. How do we know it's working? How do we test it? Well, we have a few commands we can use. Remember, EIGRP routers form adjacencies. So they have neighbors they're going to talk to. The show IP EIGRP neighbors command will show you all the adjacencies. It'll show you for how long they've been talking to them, right? And their IP addresses. The show IP protocols command. We looked at this for examining RIP. Well, I can do the same thing for EIGRP. Show IP protocols gives me detailed information about what the EIGRP protocol is doing. It tells me its AS, it tells me its neighbors, it tells me the last time it received or sent updates. It even tells you what the administrative distance is. Ultimately, of course, the proof is in the pudding. Look at the routing table. A router's routing table is the truth. This defines what that router knows about. Well, EIGRP routes in the routing table are displayed with a D. I know it doesn't make much sense. RIP was R, C was directly connected, S was static. They picked D for EIGRP. So if what we notice here, we're seeing a bunch of directly connected routes and then additional routes learned via EIGRP. And that concludes our brief look at this protocol. EIGRP is a piece of cake to set up. It's very scalable, and it's reliable. It provides security. Honestly, if you can get away with running EIGRP, that's the protocol to go with. But its big limitation is it only works on routers from these guys right here, from Cisco. If you've got anything else in your environment, HP, Dell, Enterasys, whatever, this is not an option for me. And I have to either use RIP or one of the more advanced distance vector protocols. For this week's lab, make sure that to take the RIP version 2 lab and using that exact same lab, enable EIGRP. Remember, once you turn the protocol on and share networks, you will see the adjacencies form right there in the CLI. As always, feel free to reach out to me if you have any questions, and I'll see you in class.